Alright, hi guys, it's Mr. C, and today we're going to do our Saxon level, our lesson 82. This is volume of a rectangular prism. So we're going to be looking at volume today. It's not a really complicated concept, but it's going to take some practice. Now before we get there, we're going to go through some mental math and some problem solving, and then we'll get to the lesson. So let's start with our mental math. What I'm going to do is I'm going to read it out loud. I'm going to give you a few seconds to think of the answer on your own, and then I'm going to go through the answer, okay? So the first one is probability. What is the probability of rolling an even number on a number cube? Alright? Now remember, a number cube has 6 sides and even numbers, so that would be 3 of the 6 sides. So 3 out of 6 reduces to 1/2. So it's a 1 out of 2 chance of rolling an even number. Alright, B is 284 minus 150. The answer to that is 134. C, $1.99 plus $2.99. Remember on this, an easy thing is just to round up and then subtract the difference. So if we round to $2 and $3, $2 plus $3 is 5, subtract the 1 cent, so it's going to be $4.98. On D, what is 1/3 of $7.50? Remember, $7.50, 75 divided by 3 is 25, so we just add the 0 there, and that would be $2.50. A decimal practice on E, 2.5 times 10. Let's just shift the decimal over 1, so that gives us 25. F is 800 divided by 40. And on that one, we can just use our canceling to get rid of those 2 extra zeros. So it's really just 80 divided by 4. 80 divided by 4 is 20. G, how many ounces are in a cup? You either remember this one or you don't. The answer is 8 ounces. And then finally, 10 times 10 minus 1 divided by 3 minus 1 divided by 4 plus 1 divided by 3 equals 3. Alright, so that's our mental math for today. Let's do our problem solving. This is a good practice for algebra coming up. So I'm going to read the problem, give you a second to think about it, and then I'm going to walk through the answer. 1/5 of Ronnie's number is 1/3. What is 3/5 of Ronnie's number? So think about, how would you solve that? First we have to think about how to rewrite that. So 1/5 of Ronnie's number, 1/5 of a number, we'll just call the number x because we don't know what it is, equals 1/3. Now knowing that, we can solve for x. Because we have 1/5, all we have to do to get rid of 1/5 x, that's like x divided by 5, is multiply it by 5. So we can just multiply that by 5 over 1. Those will cancel out and just leave us x. Now if we do it to this side of the equation, we have to also do it to this side of the equation. So times it by 5 over 1, and then that would be 5 over 3, right? So x equals 5/3. So we know what x is. If we know what x is, what is 3/5 of Ronnie's number, or x? What is 3/5 of x, and x is 5/3. So we're just multiplying those together basically. And if we do that, those cancel out and that just leaves 1. So 1 equals x. Now we can check our work on here. If x equals 1, and then what's 3/5 of Ronnie's number? It would be 5/3 because those cancel out and equal 1. That might seem complicated. That's why we're practicing it now. You're going to have a lot of problems like this in the next few years. So it's good to practice them. Alright, let's move into the lesson today, looking at volume of a rectangular prism. Now, come on. Volume is the amount of space inside something. So remember, just the outside surface, that's our area or our surface area. And sometimes we look at the surface area of a single face. Sometimes we look at the total surface area, so we'd have to calculate all the different faces. Now as it shows here, some cubic units, that's how we measure volume. Some are small, like a cubic centimeter. A cubic inch is going to be slightly bigger, or we might look at cubic feet or cubic meters, all right? Much larger spaces. So let's look at this first one. How many 1-inch cubes are needed to form this rectangular prism? Now they told us it's 5 inches across, 3 inches deep, and 4 inches high. If we're looking for the number of cubes, we can do 1-inch cubes here. So if we have the 5, let's just extend that up and put that in 5 columns. And here we're going to go like that too. And we can pull these across, and it kind of shows 1, 2, 3. Oh, I shouldn't have done that. That needs to extend up. All right. So those are basically our cubes. Now we have to count it through as well, like that. And then if this goes up into 3, then that will come over. So we can kind of look at a visual representation. Now we know from doing this previously that we can just count these cubes, right? So if we've got 5 across here and it's 3 levels, that's 5 times 3, or 15 cubes on the bottom level. Then we just count that by 4 levels, so 15 cubes times 4, that's going to leave us with 60 total cubes, right? So we can visually look at that. Now it's going to be a lot easier if we just do it mathematically and write it in an equation. But sometimes it's helpful to look at it. So if you need to draw it out, go ahead and do that. Now they'll show the same thing. They just took one level of that and showed a diagram and found their 60 cubes. Now notice in this example that we took the length times the width times the height. That's our formula for volumes. Volume equals length times width times height. And we can just write those together. Remember, if you have things that aren't separated, that means multiply. We could also do length times width times height, or we could do those in parentheses to represent them. Those all mean multiply. Okay? So that's our formula for volume. Length times width times height. Alright, so let's practice this. What's the volume of a cube whose edges are 10 centimeters long? So if we look at this, and we have 10 centimeters, if it's a cube, that means it's even, right? So 10 centimeters, if we're gonna, this is beautiful here, by 10 centimeters by 10 centimeters, we have our formula, 10 times 10 times 10. Now remember, just like when we calculate area, we're not just multiplying the number, we're also multiplying the unit. So it's 10 centimeters by 10 centimeters by 10 centimeters. So we do the tens first. 10 times 10 is 100, times 10 is 1,000. And then we multiply the centimeters. Centimeter times centimeter is squared centimeters, times by another centimeters is centimeters cubed. Now you can write that one of two ways. You can say 1,000 cubic centimeters. And that's how the book will often write it. I never see it like that in real life. Everywhere I look where I use math, we do it 1,000 centimeters cubed. Now remember, the 3 has to be after the centimeters. If we wrote it 1,000 cubed centimeters, that actually says that the 1,000 should be cubed, which would be 10,000 times 1,000. It's a lot. It's like a million. So don't do it that way. Make sure that it looks like this, okay? 1,000 centimeters cubed. Alright, so they're going to show in a diagram here. If you wanted to draw it out, you could draw all 10 centimeters over by 10 centimeters, go 10 centimeters up, and you would see that in that total box, there's going to end up being 1,000 little cubes. That's going to take you a long time to draw, so I don't recommend it. So it's good just to know the formula here. Alright, let's try another one. Here the volume of a rectangular prism is 4 feet long by 3 feet wide by 2 feet high. 2 feet. See how I know how to draw? 2 feet. Alright, so if we want to draw that out, we can draw that up like that. Get our pretty box. Alright. But what matters here is the units, right? 4 feet times 3 feet times 2 feet. Now we can do this with mental math. 4 times 3 is 12, times 2 is 24. Feet times feet is feet squared, times feet is feet cubed. So we have feet cubed. Now remember, we want to do our order of operations here. So we first look to see when we're doing our calculation, are there parentheses? No. Are there exponents? Yes, there would be. So if we do feet times feet times feet, that's going to give us an exponent of 3. But in the original calculation, we don't have to worry about that because we're just multiplying. So we're just multiplying straight across. Okay? Here they've written it as 4 feet times 3 feet times 2 feet. And you can just parse that out like we did and get your 24 cubic feet. All right, one more example. Here, Allison put small cubes together to build larger cubes. So she made a table to record her stuff, and this is a good thing to do, is to use a table to kind of show your data. So she says the length is 2, 3, 4, 5. You're going to see some patterns developing here. The volume would be 8, 27, 64, 125. Now you can think, what kind of pattern is that? Here we're just going up by 1 each time, but what's the relationship between 8 and 2, 27 and 3, 64 and 4? It's because the number is cubed. So 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. So we're just cubing the numbers. Given this pattern, the rule, so we just discovered the rule, it helps us to see that for this number, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. So in other words, the rule here is volume equals whatever the number is cubed. All right? And that will come in handy when we start developing other formulas. Now for today's homework, you're just going to do a bunch of practice finding the volume for a rectangular prism. So we have this practice set. If you want to go through it, you can. I'm just going to leave this up for a second. But then you'll be able to just go on and do your problems from lesson 82. So here's our practice set, and I'll leave that up for a second, and then you can get to your work. All right?